You're now on episode 7 of 15 in this AWS Certified Solutions Architect Associate SAA-C03 practice playlist. We'll continue with questions 61 through 70, one question at a time. Question 61. A company needs to run a critical application on AWS. The company needs to use Amazon EC2 for the application's database. The database must be highly available and must fail over automatically if a disruptive event occurs. Option A. Launch two EC2 instances, each in a different availability zone in the same AWS region. Install the database on both EC2 instances. Configure the EC2 instances as a cluster. Set up database replication. Option B. Launch an EC2 instance in an availability zone. Install the database on the EC2 instance. Use an Amazon Machine Image (AMI) to back up the data. Use AWS CloudFormation to automate provisioning of the EC2 instance if a disruptive event occurs. Option C. Launch two EC2 instances, each in a different AWS region. Install the database on both EC2 instances. Set up database replication. Fail over the database to a second region. Option D. Launch an EC2 instance in an availability zone. Install the database on the EC2 instance. Use an Amazon Machine Image (AMI) to back up the data. Use EC2 automatic recovery to recover the instance if a disruptive event occurs. The correct answer is A. Launch two EC2 instances, each in a different availability zone in the same AWS region. Install the database on both EC2 instances. Configure the EC2 instances as a cluster. Set up database replication. Explanation. Deploying in different AZs with replication ensures high availability and automatic failover within the same region. Why not option B? AMI backup in CloudFormation does not provide high availability or failover, it's a recovery method. Why not option C? Use different AWS regions. Interregion failover adds latency and complexity, not ideal for HA within a region. Why not option D? EC2 automatic recovery only restarts the same instance, does not offer redundancy or replication. Question 62. A company's order system sends requests from clients to Amazon EC2 instances. The EC2 instances process the orders and then store the orders in a database on Amazon RDS. Users report that they must reprocess orders when the system fails. The company wants a resilient solution that can process orders automatically if a system outage occurs. Option A. Move the EC2 instances into an auto-scaling group. Create an Amazon Event Bridge, Amazon CloudWatch Events, rule to target an Amazon Elastic Container Service Amazon ECS task. Option B. Move the EC2 instances into an auto-scaling group behind an application load balancer, ALB. Update the order system to send messages to the ALB endpoint. Option C. Move the EC2 instances into an auto-scaling group. Configure the order system to send messages to an Amazon Simple Queue service, Amazon SQS queue. Configure the EC2 instances to consume messages from the queue. Option D. Create an Amazon Simple Notification Service, Amazon SNS topic. Create an AWS Lambda function and subscribe the function to the SNS topic. Configure the order system to send messages to the SNS topic. Send a command to the EC2 instances to process the messages by using AWS Systems Manager Run command. The correct answer is C. Move the EC2 instances into an auto-scaling group. Configure the order system to send messages to an Amazon Simple Queue service, Amazon SQS, queue. Configure the EC2 instances to consume messages from the queue. Explanation: SQS ensures order messages are retained and retried if instances fail, decoupling processing and improving fault tolerance. Why not option A? Event bridge to ECS task. Adds unnecessary complexity and doesn't ensure message durability. Why not option B? ALB alone. ALB doesn't provide message durability or retry capabilities. Why not option D? SNS plus Lambda plus Systems Manager. Complex and fragile setup not designed for resilient EC2 message consumption. Question 63. A company runs an application on a large fleet of Amazon EC2 instances. The application reads and writes entries into an Amazon DynamoDB table. The size of the DynamoDB table continuously grows, but the application needs only data from the last 30 days. The company needs a solution that minimizes cost and development effort. Option A. Use an AWS CloudFormation template to deploy the complete solution. Redeploy the CloudFormation stack every 30 days and delete the original stack. Option B. Use an EC2 instance that runs a monitoring application from AWS Marketplace. Configure the monitoring application to use Amazon DynamoDB streams to store the timestamp when a new item is created in the table. Use a script that runs on the EC2 instance to delete items that have a timestamp that is older than 30 days. Option C. Configure Amazon DynamoDB streams to invoke an AWS Lambda function when a new item is created in the table. Configure the Lambda function to delete items in the table that are older than 30 days. Option D. Extend the application to add an attribute that has a value of the current timestamp plus 30 days to each new item that is created in the table. Configure DynamoDB to use the attribute as the TTL attribute. The correct answer is D. Extend the application to add an attribute that has a value of the current timestamp plus 30 days to each new item that is created in the table. Configure DynamoDB to use the attribute as the TTL attribute. Explanation: TTL, time to live, is the simplest, built-in way to expire items in DynamoDB without custom code or infrastructure. Why not option A? Rebuilding CloudFormation stacks. Inefficient, manual, and not suited for continuous data retention. Why not option B? Marketplace app plus script. Adds infrastructure and manual scripting, increasing cost and complexity. Why not option C? Streams plus Lambda deletion. More complex than needed compared to using native TTL. Question 64. A company has a Microsoft NET application that runs on an on-premises Windows server. The application stores data by using an Oracle Database Standard Edition server. The company is planning a migration to AWS and wants to minimize development changes while moving the application. The AWS application environment should be highly available. Which combination of actions should the company take to meet these requirements? Choose 2. Option A. Refactor the application as serverless with AWS Lambda functions running. Net Core. Option B. Rehost the application in AWS Elastic Beanstalk with the NET platform in a multi-AZ deployment. Option C. Replatform the application to run on Amazon EC2 with the Amazon Linux Amazon Machine Image, AMI. Option D. Use AWS Database Migration Service, AWS DMS, to migrate from the Oracle database to Amazon DynamoDB in a multi-AZ deployment. Option E. Use AWS Database Migration Service, AWS DMS, to migrate from the Oracle database to Oracle on Amazon RDS in a multi-AZ deployment. The correct answers are B and E. Option B. Rehost the application in AWS Elastic Beanstalk with the NET platform in a multi-AZ deployment. Option E. Use AWS Database Migration Service, AWS DMS, to migrate from the Oracle database to Oracle on Amazon RDS in a multi-AZ deployment. Explanation: Elastic Beanstalk supports NET and provides high availability, and Oracle on RDS supports minimal database changes and HA via multi-AZ. Why not option A? Refactor as serverless. Requires significant development changes. Why not option C? Replatform to Amazon Linux. NET on Windows is incompatible with Linux without substantial changes. Why not option D? Migrate to DynamoDB. Requires major application re-architecture. Question 65. A company runs a containerized application on a Kubernetes cluster in an on-premises data center. The company is using a MongoDB database for data storage. The company wants to migrate some of these environments to AWS, but no code changes or deployment method changes are possible at this time. The company needs a solution that minimizes operational overhead. Option A. Use Amazon Elastic Container Service, Amazon ECS, with Amazon EC2 worker nodes for compute and MongoDB on EC2 for data storage. Option B. Use Amazon Elastic Container Service, Amazon ECS, with AWS Fargate for compute and Amazon DynamoDB for data storage. Option C. Use Amazon Elastic Kubernetes Service, Amazon EKS, with Amazon EC2 worker nodes for compute and Amazon DynamoDB for data storage. Option D. Use Amazon Elastic Kubernetes Service, Amazon EKS, with AWS Fargate for compute and Amazon Document DB with MongoDB compatibility for data storage. The correct answer is D. Use Amazon Elastic Kubernetes Service, Amazon EKS, with AWS Fargate for compute and Amazon Document DB with MongoDB compatibility for data storage. Explanation: EKS allows lift and shift of Kubernetes workloads, and Document DB provides a managed, compatible MongoDB backend. Why not option A? ECS with EC2 and MongoDB on EC2 requires infrastructure and maintenance for MongoDB. Why not option B? ECS with Fargate and DynamoDB, not MongoDB compatible, requires app changes. Why not option C? EKS with EC2 and DynamoDB. DynamoDB is not a drop-in replacement for MongoDB. Question 66. A telemarketing company is designing its customer call center functionality on AWS. The company needs a solution that provides multiple speaker recognition and generates transcript files. The company wants to query the transcript files to analyze the business patterns. The transcript file must be stored for 7 years for auditing purposes. Option A. Use Amazon Rekognition for multiple speaker recognition. Store the transcript files in Amazon S3. Use machine learning models for transcript file analysis. Option B. Use Amazon Transcribe for multiple speaker recognition. Use Amazon Athena for transcript file analysis. Option C. Use Amazon Translate for multiple speaker recognition. Store the transcript files in Amazon Redshift. Use SQL queries for transcript file analysis. Option D. Use Amazon Rekognition for multiple speaker recognition. Store the transcript files in Amazon S3. Use Amazon Textract for transcript file analysis. The correct answer is B. Use Amazon Transcribe for multiple speaker recognition. Use Amazon Athena for transcript file analysis. Explanation: Amazon Transcribe supports multi-speaker recognition, and S3/Athena enables low-cost, long-term storage with on-demand analysis. Why not option A? Recognition for speaker recognition. Recognition is for image and video analysis, not audio transcription. Why not option C? Amazon Translate. Translate is for language translation, not speech recognition. Why not option D? Textract for transcripts. Textract is used for extracting text from documents, not audio transcripts. Question 67. A company needs the ability to analyze the log files of its proprietary application. The logs are stored in JSON format in an Amazon S3 bucket. Queries will be simple and will run on demand. A solutions architect needs to perform the analysis with minimal changes to the existing architecture. Option A. Use Amazon Redshift to load all the content into one place and run the SQL queries as needed. Option B. Use Amazon CloudWatch logs to store the logs. Run SQL queries as needed from the Amazon CloudWatch console. Option C. Use Amazon Athena directly with Amazon S3 to run the queries as needed. Option D. Use AWS Glue to catalog the logs. Use a transient Apache Spark cluster on Amazon EMR to run the SQL queries as needed. The correct answer is C. Use Amazon Athena directly with Amazon S3 to run the queries as needed. Explanation: Athena allows direct querying of JSON files in S3 with no infrastructure or setup, meeting on-demand, low-overhead requirements. Why not option A? Redshift requires data loading and maintenance, not optimal for on-demand queries. Why not option B? CloudWatch logs, not applicable unless logs were originally sent to CloudWatch. Why not option D? EMR with Spark adds significant overhead for simple queries. Question 68. A company wants to improve its ability to clone large amounts of production data into a test environment in the same AWS region. The data is stored in Amazon EC2 instances on Amazon Elastic Block Store, Amazon EBS, volumes. Modifications to the clone data must not affect the production environment. The software that accesses this data requires consistently high I/O performance. Option A. Take EBS snapshots of the production EBS volumes. Restore the snapshots onto EC2 instance store volumes in the test environment. Option B. Configure the production EBS volumes to use the EBS multi-attach feature. Take EBS snapshots of the production EBS volumes. Attach the production EBS volumes to the EC2 instances in the test environment. Option C. Take EBS snapshots of the production EBS volumes. Create and initialize new EBS volumes. Attach the new EBS volumes to EC2 instances in the test environment before restoring the volumes from the production EBS snapshots. Option D. Take EBS snapshots of the production EBS volumes. Turn on the EBS Fast Snapshot Restore feature on the EBS snapshots. Restore the snapshots into new EBS volumes. Attach the new EBS volumes to EC2 instances in the test environment. The correct answer is D. Take EBS snapshots of the production EBS volumes. Turn on the EBS Fast Snapshot Restore feature on the EBS snapshots. Restore the snapshots into new EBS volumes. Attach the new EBS volumes to EC2 instances in the test environment. Explanation: Fast Snapshot Restore ensures immediate availability of volumes from snapshots with high performance, ideal for test cloning. Why not option A? Instant store volumes. Not persistent and not attachable after stop/start, not suitable for cloned environments. Why not option B? Multi-attach. Only available for specific volume types, not meant for test cloning across environments. Why not option C? Initialize new EBS volumes before restore. Inefficient and lacks performance boost from fast snapshot restore. Question 69. A company hosts its application on AWS. The company uses Amazon Cognito to manage users. When users log into the application fetches required data from Amazon DynamoDB by using a REST API that is hosted in Amazon API Gateway. The company wants an AWS-managed solution that will control access to the REST API to reduce development efforts. Option A. Configure an AWS Lambda function to be an authorizer in API Gateway to validate which user made the request. Option B. For each user, create and assign an API key that must be sent with each request. Validate the key by using an AWS Lambda function. Option C. Send the user's email address in the header with every request. Invoke an AWS Lambda function to validate that the user with that email address has proper access. Option D. Configure an Amazon Cognito user pool authorizer in API Gateway to allow Amazon Cognito to validate each request. The correct answer is D. Configure an Amazon Cognito user pool authorizer in API Gateway to allow Amazon Cognito to validate each request. Explanation: Using Cognito as an authorizer provides a fully managed and scalable way to authenticate and authorize users at the API Gateway layer. Why not option A? Lambda authorizer requires custom code and adds more management overhead. Why not option B? API key per user, not intended for user-level authorization, better suited for usage plans. Why not option C? Email in header plus Lambda, insecure and custom, increases development effort. Question 70. A company is developing a marketing communications service that targets mobile app users. The company needs to send confirmation messages with short message service, SMS, to its users. The users must be able to reply to the SMS messages. The company must store the responses for a year for analysis. Option A. Create an Amazon Connect contact flow to send the SMS messages. Use AWS Lambda to process the responses. Option B. Build an Amazon Pinpoint journey. Configure Amazon Pinpoint to send events to an Amazon Kinesis data stream for analysis and archiving. Option C. Use Amazon Simple Queue Service, Amazon SQS, to distribute the SMS messages. Use AWS Lambda to process the responses. Option D. Create an Amazon Simple Notification Service, Amazon SNS, FIFO topic. Subscribe an Amazon Kinesis data stream to the SNS topic for analysis and archiving. The correct answer is B. Build an Amazon Pinpoint journey. Configure Amazon Pinpoint to send events to an Amazon Kinesis data stream for analysis and archiving. Explanation: Amazon Pinpoint supports two-way SMS and integrates directly with Kinesis for durable analytics and storage. Why not option A? Amazon Connect, designed for voice contact centers, not SMS. Why not option C? SQS to distribute SMS. SQS does not support direct SMS functionality. Why not option D? SNS FIFO topic with Kinesis. SNS does not support SMS replies or FIFO for SMS messaging. You made it through this episode. If the questions and explanations were helpful, follow the channel and share the video with your certification study group or colleagues. Continue the playlist whenever you're ready.